All right, so Abdullah Mohamed Abba is a tutor for chemistry lesson 1, a graduate of the Kwame Nkrumah University of Science and Technology, BSc Chemistry, and MEd Science, University of Education, Winneba. Today's lesson is on atomic structure. We are going to look at the basis of the atom, vis-a-vis the theories and postulates put forward by scientists to support the subatomic particles, namely electrons, protons, neutrons, that make up the structure of the atom. So today's lesson is going to be on atomic structure. And so to start with, we'll look at the Dalton's atomic theory. Dalton is one of the early scientists that investigated the structure of the atom. In fact, he was one of the very first scientists to have looked into the structure of the atom and put forward some postulates. Most of the postulates were contested, and others were also approved by subsequent scientists. Good. And so the very first of the postulates is that the element, an atom, is made up of tiny particles. That atom is made up of tiny particles. And the tiny particles are said to be indivisible. Indivisible such that they cannot be divided further. He did say that all atoms of a given element are identical. That is, they have the same size and then mass. They are identical. Then again, the atoms of a given element are different from those of other elements. That is to say, in other words, the atoms of different elements can be distinguished from one another by their respective relative weights. And that is why if you take elements, you have the mass number and then the atomic number. Let me demonstrate that on the board for you to see. And so if you take, say, sodium atom, that is Na. It has a mass of 23, and the atomic number of what? 11. You understand that? This property distinguishes it from another element, say carbon. You understand that? Which is 12, 6. So see that the weight of the carbon atom is different from that of what? The sodium atom. Are you getting that? Yes. So atoms can be distinguished from one another with respect to their relative weights. See, they have different. The weight of this is 23, and that of this is what? 12. And what we mean by weight is the mass numbers. Is that clear? Good. Furthermore, we said atoms of an element can combine with other elements, okay, to form chemical compounds. And under this, when you go to the laws of chemical combinations, that is under states of matter, it tells us how this combination is done, in what ratios. We have laws of chemical combinations. You understand that? Be it the law of what? Definite proportion. Or the law of what? Conservation of what? Matter or mass. You understand that? That gives details about how these atoms are combined to form compounds. Is that clear? Good. Finally, that indicated that atoms cannot be created, divided into smaller particles, nor destroyed in a chemical process, which we popularly say atoms can neither be created nor destroyed. You understand that? Yes, exactly. In other words, a chemical reaction simply changes the way atoms are put together, but the atoms themselves do not what? Change in different forms. You understand that? Good. And so, in effect, these are the 5 postulates put forward by Dalton in respect of the structure of the atom. Okay? Good. Now, many of the postulates were disapproved by subsequent scientists. And so we are going to look at that. But even before that, we have what we call the limitation of Dalton's theory. when we talk about limitations, we're looking at areas that he failed to talk about. Even with the postulates he has put forward, there are loopholes that people have detected that, okay, he should have said A instead of B. You get that? So those are considered as what? The limitation to the theory. Do you get that? Good. The first one is that Dalton's atomic theory could not explain the law of gaseous volumes. The postulates is proved, 5 postulates could not explain the law of what? Gaseous volume. The next one is that Dalton's atomic theory could not explain why atoms of different elements have different masses, sizes, and what? Valencies, and so on. Which means he could not explain isotopy. The existence of what? Atom of the same element with the same, what? Different masses. You understand that? Yes, he could not explain that. The theory could not explain that. Then furthermore, Dalton's theory could not explain why atoms of different elements combine with each other to form molecules. Then again, Dalton's theory could not also explain the nature of forces that bind atoms together in molecules. That is talking about bonding. He didn't give enough insight about how these atoms would combine to form compounds. Then finally, the theory could not also explain the fundamental particles that make up the elements or what? Compounds. So in effect, these are the 5 limitations to the Dalton's atomic theory. Dalton's atomic theory. Now, we stated 5 postulates. 5 of the postulates. 3 of them were disapproved. 3 of the postulates were disapproved. And if you look forward, you see that most of these questions, I think I saw one of these as past questions, that we should list the Dalton's atomic theory that were disapproved. And you don't just disapprove. If you disapprove, you must bring in what you think is right. You understand that? Good. So these are the disapproved Dalton's atomic theory. 1, atoms can neither be created nor destroyed was disapproved. It could not stand the test of time. In effect, if you say it's disapproved, means that atoms can be created and they can also be what? Destroyed. Then atoms are the smallest indivisible particles of matter that could not also stand the test of time. Maybe those days, but atoms can be divided now into subatomic forms or smaller forms. Finally, all atoms of the same element have the same mass and size. That has also been what? Disapproved, because we have isotopes, isn't it? Yes, so it disapproves that. So these 3 postulates were disapproved. Okay. Now, after the disapproval, those that disapproved brought in different, or what we call the modern theory, together with his postulates, with the disapproval and what they think is right, brought what we call the modern theory. What does it say? In view of the new discoveries about atoms, Dalton's atomic theory was modified as follows. So that's what we call modification. If there are limitations and the limitations were modified, we need to know what they are, isn't it? 1, atoms are no longer indivisible, because that indicated that they were divisible. Okay, no, they were indivisible, isn't it? And we're saying that they are no longer indivisible because they can be divided. You understand that? Yes, they can be divided as complex structure of subatomic particles. So it can be divided into electrons, protons, and then what? Neutrons. Do we get that? Good. Then atoms of the same element may possess different masses. And that's why we have isotopes. That's why isotopes exist. So the existence of isotopes disapproves the fact that atoms cannot form or cannot be exhibited in different forms. You get that? Good. Then certain atoms of different elements have the same relative masses, but their chemical properties are entirely different. And that's what we mean by what? Isobars. Not isomers or isotopes. Isobars. Okay? Then, finally, although the atom is considered or is composed of subatomic particles, it may, or it is still the smallest unit that takes part in chemical reactions. So it's still the smallest unit, even though we can still what? Divide them into, but it's still considered as what? The smallest unit that can take part in a chemical reaction. Are we okay? Okay.